Welcome everyone. The purpose of today of this webinar is to show you a bit how in Stratio we offer a centralized and unified data access layer. We'll talk a bit about how using GenAI we have managed to improve a bit the experience and the usage of this technology in different contexts. We can do a quick demo, and then I want to show you also a use case where it shows basically how using different tools of the stack that we will present has potentially increased the levels of trust and governance together with GenAI. So just a quick recap. What is Stratio? If some of you do not know us, we are a company around 500 people based in Spain, but with presence in different areas in Europe and Latam. It was founded using technical disruption with the transition to the public cloud. We used a heavy use of Kubernetes and distributed applications, and now even more with the appearance of the generative AI tools, we are also going into the landscape, providing also the semantic layer and making the generative AI work in much better in the different enterprise contexts that we encounter with our clients. Okay, so we will speak a bit about what's data fabric in our view, data mesh, concept of data mesh, and then generative AI. Some of our clients, I think, just to put some context, Stratio is a horizontal platform. It's a technological platform that we will cover several layers of the stack. But you can see, I mean, from this slide that we have presence in different customers, and we do different things depending on the vertical that we work on. As we are a horizontal platform, we have common pieces, but at the same time, we also have certain customizations depending on the use case or of the different verticals according to our clients' needs. Okay, so I'll start with some problems and misconceptions that we found in the market. I think whenever we go into the market and explain our product, I think it's commonly known that we encounter certain challenge, right? I mean, our client says, okay, we have bad data. We need to some sort of unify our data strategy around governance capabilities. We cannot use GenAI, or it is not actually giving us the results that we were expecting. We have certain trust or governance issues. So everything, I mean, around quality, governance, certain analytical issues that come up due to the use of bad data or not existing data, even because they have data silos. We encounter them commonly, and it's something that is our landscape to introduce the data fabric concept. Okay, so we kind of move in this area, and also we expect to see more and more now with the inclusion of the generative AI technology that companies want to apply generative AI in their business processes, but also want to keep ensuring certain guarantees on what they are doing, like securing their data, having accurate answers from the engine, or maybe even go to a compliance or regulatory scenarios where the responses must be exact, accurate, and also avoid things like hallucinations or lack of clarity. So GenAI is really good. We are seeing it in a lot of expectations, and the market is basically looking at it, but at the same time, it's imposing new challenges and requirements on the organizations from the point of view of how do I keep ensuring things like trust data, security, how do I maintain and operate these systems, or even how I monitor and keep track of what was answered and questioned in the system. So the challenge really lies on how to apply these technologies in the enterprise landscape when a company starts to investigate these technologies. Okay. A bit of data fabric. I won't go into the definition of what data fabric, but I think it's a common knowledge that Gartner and Forrester or other consultancy companies on the market itself is recognizing this new trend, basically in the sense that we have started, or the market has realized that we need to somehow start automating strategies around our data. I mean, we need to treat their data as an asset, and then treating it like an asset means we need to give them processes, and we need to, in many cases, automate this process to make it usable. So the volume of data is huge at this point in many companies, and the challenges that we encounter is basically that they want to analyze, extract value from it, but due to the volume in certain cases, it's not that it's a technological impediment to actually do that, but it's more of a governance perspective on how they actually manage this life cycle management of the different processes in the company. So Gartner has recognized this as a new wave, and actually has already give some feedback on how they actually think about generative AI linked into this concept, which is, I put this paper here because it's an interesting text where they basically talk about the union between the LLM system, so the generative AI, with the usage of active metadata. And this is really the value proposition that we are positioning in Stratio. I mean, we have, from the Stratio point of view, we have certain tools that actually are very focused on giving governance tools, but also with the target of actually providing business context and make the data usable. So when we talk about active metadata, it's about giving the data business context, giving about semantics and meaning inside the whole landscape of technologies, but also using metadata to make actions and automate actions inside the platform. So when we talk about active metadata, it's basically the use of certain mechanisms that we can share with the LLMs to actually take actions and improve the performance and the ability of them to basically answer questions, because they have more business knowledge, they have more tools, and they can basically actuate and respond in a faster and secure and more secure way. Okay, so I think we combine two, and we will dig a bit more onto this, that we have this active metadata information from the governance perspective, but also all the security and mechanisms to access data safely with the data fabric tools that we provide, and I will dig a bit more into that. Okay, so Gartner recognized us already on a cool vendor report, and I will directly go to the solution. Okay, why we say we automate, we are generative AI data fabric, and how we really combine all these concepts together. So the platform itself, it's I think if I have to simply explain what we do, is a combination of data fabric, where we govern, we give business meaning, we secure the data, and then we do analytics on top. So that basically all the stack is combined and look for automations in different levels. Plus, if we combine this with the generative AI engines, where it allows us to use all this knowledge to basically talk to your data, even search for data advice, explainability, or recommendations on different levels. It can be using our data, but also mixing general knowledge with the data that you see inside your company. So really the combination between these two is what we really position ourselves as a good provider of, first, secure generative AI use case, but also more accurate and more or targeting more the enterprise data. That is really the problem when we actually go into companies and want to use generative AI technology. Just if I go from bottom to top, our technology starts from an auto discovery process. Okay, this auto discovery process, what it looks for is to detect and discover what is the data inside all these data stores. Okay, we have a number of connectors and the basic mechanisms to actually build what we call a data catalog. Okay, this is kind of the foundation to start using the different data available on the different data stores that any client might have available already. So the first thing is to auto discover and scrap what they already have. Okay, once we have that, we automatically link that to the virtualization layer. Okay, that means basically that if I take the basic usage of the platform, what we provide in here is two important capabilities. First is the abstraction of a catalog into a unified data access layer, which is the virtualization, basically allowing anyone or the user to actually go and see a catalog of tables without actually knowing where the origin of that table or that data is actually stored. So we abstract the complexity of connecting to multiple data stores and leading with the different technical complexity that might consist of. Also, the second important advantage of this virtualization is the capability of blending data between multiple data stores. I mean, the virtualization itself not only allows you to actually access the data inside these data stores, but also mix this data together between multiple tables available in this catalog. So really what we put in here is the abstraction of the technical complexity of connecting multiple data stores, but also the engine to actually resolve data mixtures between different tables available on different origins. Okay, what do we put on top? We have the basic catalog. It represents really the technical information that we find in the multiple data stores. We also put on top not only the standard governance capabilities like definition of business terms, lineage, quality definition, and so on, but we also put what we call the semantic layer or the business data layer. That means basically that the governance tool in Stratio is kind of the central point where we control not only what we have, as other governance tools does, but also how we can use metadata and certain controls to actually define and expose the data to our final consumers. Okay, so in this layer, what we provide is tools and mechanisms for the user to actually define what should be the final business table or business view that the consumer is gonna query the data. So it's important to know that this layer usually consists of logical models or more business-oriented language that is closer to a self-consumption consumer, basically. So they look into the catalog, are more keen to actually go and understand what this table has than rather than what they have on the technical part. The challenge here is that we need to map one to the other. Okay, to create business view, we basically need to tell the system how they should go and access this technical layer to build up automatically this representation of data that will be exposed to reporting, analytics, machine learning models, and so on. So this is the key aspect that we will dig on later on the presentation, how we actually do that process of creating that semantic layer that then is used for GenAI and even more for standard consumers that understand much better and the data in this shape. Okay. Things that we have on top, we are also building knowledge graphs. With this, we mean basically a representation of what are the relationships between concepts and available data, or even business concepts that we have defined in the tool. So we call it knowledge graph because we combine not only the technical data, but also the business data, processes, and basically any kind of assets that is defined in the platform is basically represented here with the relationship between these assets or concepts. We also have the definition of data quality. We can do that on top of business layer, on the business layer, or also on the technical layer. And it means basically that from the governance point of view, we put the expectations of the data that we wanna have. So let's say I'm looking to have a certain range in a numerical column. So I can put those things, or it can be technical rules, or it can be more business rules, define those from a central perspective in my tool, and then the system will automatically go and measure when they treat that data inside the platform. So the advantage here is that I put a single definition on top of this catalog or the business layer, and then the system can automatically measure or schedule how it's gonna measure this quality during time. So the advantage really of, and why we say it's automated data quality, is because we take advantage in many cases that the data is moving to actually measure the quality and the expectations that we have defined centrally in our governance tool. Security is the same. I mean, we are exposing data, so one of the things that are key to actually expose this data with guarantees is to expose it with security. Okay, and we talk about security to choose if I expose one table or not, but also more complex rules that, like anonymization of certain columns, filtering of certain records. So more fine-grained security policies can be applied either to the business data views or to the technical tables that are available from the original data sources. MDM, and this is an interesting capability. I mean, on top of all this, I mean, we have a full governance tool, we have a virtualizer. We will see later that also we have ETL capability, so we can actually have a module to treat master records, let's say. So this is a common problem in many industries, that I need to have a source of truth that is composed by or by the golden records or by the master data. So that data has specific needs that need to be handled, like replication of removing duplicates, detecting kind of similarity between different names or columns. So there are certain things that needs to be identified and then corrected to maintain a healthy and high quality data set that can be used across the organization. So this kind of data and these kind of capabilities are built up in this module, taking the advantage that we already have all the other tools and integrated with the all the governance capabilities. So it's not something that you build up separately in the platform. Then we have Rocket on top of it. We go to the user layer, where we basically want to do reporting, we do AI models, we want to do applications, and we make use of all the definition that we have in governance. I won't go into details, but Rocket is a full analytical suite that can offer you the tools necessary to actually build analytical assets and present them to the users. Okay. And then just to finish, we have a way of sharing this with the product marketplace, where we can basically interact with third-party consumers of this data. So by a very simple way of publishing and subscribing to certain data, you can manage also the security aspects of allowing consumers to actually read from the available data, but also control certain SLAs and service requirements when we actually share data between the consumer and the producer. And then the Gen AI, which makes use of all of this. I mean, the Gen AI is actually enriching all the experience, providing this natural language processing interface to actually make use of all the semantics, all the governance, all the processes and tools that the platform has to actually take actions or calculate new data in order to answer the different questions that we may ask to the end. We will see a bit of a demo here. I won't go into much details, but this is basically the integration when we talk about generative AI and data fabric. The key aspect here is how we inject the knowledge that we have available in our data governance tools. Think that our data governance have some business definition through ontologies, business terms, attributes, relationships. It knows where the processes lie, where the data is stored. So all this information actually provide a rich context knowledge that can be used to answer questions whenever a consumer goes and asks something in natural language processing. And this is exactly what we inject with our generative AI engines into the LLMs, okay, the models that actually answer and give an answer to our question. Here, the important part is to understand that we use all this semantic layer and information to actually give better context to the systems that can respond in a better way. But we will not give them directly the response. We will use this as some sort of a translator into task or even SQL queries that can directly be executed automatically by the system into the real data store. So in that sense, we avoid having to share all this data with the LLMs because we are only sharing the metadata and the semantics to make better translations using our model, and then using that translation to actually go directly from the user to the data store. So in that way, this is a really interesting part because it allows us to actually expose the data with security, with full governance, and don't share private data that in many cases we don't even want to share with the existing LLM models. Okay. I won't go into much detail here, but basically, I mean, it's not just to building these prompts and the actual questions to the generative AI engines. We have a net of services that actually can do some validations and improve the way we actually give this context to the system. Remember that these systems work really well if we are really consistent and specific on what we ask. So the purpose of all these things is that if the user asks a simple question like, okay, give me the KPI of sales of this month, that means that we need to inject what means in terms of sales for that company, where are that data stored, where are the deals stored, where are the amounts, all that information that is kind of embedded in our semantics and the data model is what all these agents start to interact between each other to actually build a good context that can be shared with LLM, and the LLM can then take the answer and respond properly to this question that the user is asking to its data. So really, in overall, what we achieve with this is basically reducing a lot the hallucinations or things that are not really real, but also improving the capability, the capacity and accuracy of the answers in the systems. Okay. Also, this is just a small representation of things that internally they do. I mean, not only inject this knowledge, but also do some kind of checks. Okay, we have loops internally that basically they actually go into the system and check, for example, that the translation that the LLM did was correct, right? Because imagine, I mean, an LLM is very prone to use synonyms or to use words that cannot be changed if we are talking about translating natural language processing into an SQL. The table, for example, of the name of the table cannot be changed, right? You cannot query customers instead of clients, for example. So these kind of things are really pre-checked just before actually giving an answer to our customer, to our consumer. So we really make some mechanisms that actually increment a lot the accuracy and the confidence level of our answers. Okay, and this is really the key. I mean, so from our experience, what we have seen is that usually, I mean, we start with auto discovery, we have the quality and the governance model, then we generate this BDL and data consumption, and then we kind of fine tune and start consuming that data, so we actually improve the performance even more. So really, the biggest step here and the great improve is where we pass from a 30% accuracy in our answers to an a percentage of 75, 85%. And that really is about how we pass that context to the generative AI. Okay, and that means basically that in our platform, I mean, building that semantic layer in our experience improve a lot the accuracy and the usage of these generative AI engines, because they are actually capable of answering right in a percentage that is actually, you know, significantly better than what we have whenever we actually only have governance model or other simple capabilities. Okay, I'll go to the demo very briefly. The first part is about showing the technical the technical domain. So what you see here, I mean, I'll go. So if I ask the question that tell me the sales by day, it's basically it cannot even answer. Okay. If I actually move now to the, let's go this a bit faster. So if I go now and use the business view, okay, instead of the technical view, well, it will start, you know, answering a bit better. I have already checked a technical domain, so it starts to do a bit more. Okay, in the beginning without domain, it didn't do anything. Now it does something, but it really does not do well either. I mean, really, when we start seeing improvements is when we start to see what is the relationship between this technical view, which now, I mean, the problem is that it's technical names and it cannot get any meaning, right? You see that the columns are names like columns, and it's difficult for the engine to actually extract what is really inside this column. So whenever we map a simple semantic layer to this table, we actually giving some context to these different columns, and then the system, if we ask exactly the same question again, it will actually understand much better the question, and then it actually give us the right answer. Okay. Then we can, I mean, go to the not only a question and answer, but also we can create dashboardings. It's fully integrated with our reporting tool. And then, well, you can see that it's multi-language. I mean, all these things and concepts that come from the LLM are actually present and available when we use the content. So it gives us this last mile to actually answer any kind of question to the different type of clients. It can be very specific to our model, but also it can be more exploratory capabilities like this. Okay. I'll jump straight to the last part, where we saw the security part, which is something I think it's interesting. Let's go. So if I ask here, let's go back a bit, second. Yeah. Okay. So I'm asking as a data owner. Okay. I'm asking for the list of clients. Okay. So in this case, this owner have full visibility on the data. You see that I can see the email, I can see all the information available on this customer table information, right? There is no restriction for me because I have the right to see all this information. However, if we now that we will join with a data scientist profile, what we expect the system to do is basically hide some details, because basically the data scientists do not have the right to actually see all the information in clear text. So when I actually ask the same question, give me the customers, what they expect from the system is to actually enforce certain security. And as you can see, the sensitive data like email, telephone number, name, etc., are anonymized in this case. So even though I ask exactly the same question to the engine, the answer and actually the data that I can see according to the profile and the security policy is always enforced. Okay. So what? And just to finish, a couple of more minutes. Okay, but I've seen that this is working great. I mean, it's capable of answering me, but still, I mean, what I'm worried about is, okay, relating all this mapping between the technical model and the semantic, it's a lot of effort, right? I mean, even though this actually happens, I mean, for me, it's a heavy process in the system. But Stratio, I mean, and I'm going to tell you a bit about this use case, can automatically classify that semantic to actually improve this relationship and make the relationship automatic. And this is a lot related with this use case. I mean, we have done it at the scale in big banks. I mean, where they have this problem on the regulatory part, where they actually had to govern and tag the different data that they have available on the system. So we are talking about around 4,000 definitions and around 40,000 data columns and fields that are available across 11 data stores and technology. So this is a common landscape for banks, insurance companies, and companies that really have all these teams working on this data, data and governance organization. So what is really the impact here? Using the pattern and the classification from GenAI, we basically went from a 5% classification using all these terms to more than 80 in less than 2 months, which was basically compared to what they were estimated in the beginning against 12 months. So we basically kind of improved by 92% using generative AI and all the knowledge with the scanner. We managed to improve, in 92% the times that it will cost to this bank to actually do this exercise. And even more, usually if we do this manually, the person that actually find a similar term actually will relate the similar term, but it doesn't really look for what is the best term on all the 4,000 terms that I have available, because that would be exhausting for any one of us. So the system is actually tagging even with higher probability of success and much better than even the human, because it checks also these 4,000 business terms against all the columns. Okay, so basically, I mean, just how did the Stratio help is in two things. I mean, with the unified layer, we could combine all these data stores and information in a single data access layer. And then with this automatic classification, we managed to actually give semantics to all these terms and take actions on top of it, like the security aspect that we were mentioning. We avoid, for example, users to access GDPR sensitive data that, I mean, in general, should be restricted for this kind of user. This is really the key numbers here. And this is just to finish some of the results. I mean, to see that actually how we measure how good was it tagged. Well, we have an evaluator, also manual evaluation, and also using generative AI, which basically told us, okay, you have the red one that is the not loaded, which is fair, and then the assigned manually, which is the blue one, which is basically all the amount of information that we managed to tag automatically, which are the yellow, green, and red, and the ones that were charged manually. So you compare in 2 months, I mean, the difference is quite a lot. Okay, and I think that's all. I mean, it was quick. I think I give an overview of everything. If you have questions, I'm happy to answer those. No questions? Okay. I have it here. How do you manage a client situation when there is? Okay. We don't move the data, I mean, to our system. So thanks I understand CDP as data platform, right? So I don't actually force the user to move the data into one of our systems. As we have the virtualizer, and virtualizer is using a Spark underneath. So one of the things that we can do when I do blending of data or things like that, actually I use that distributed engine to answer and the question that I get on that virtualizer. So in general, what we do is connect the virtualizer to this Cloudera cluster and then put all the semantics and the GenAI together with the virtualization on top of it. So we don't force the clients to move that away from their existing clusters. Okay. And what is the role of AI in auto discovery? Okay. The role of AI is I mean, the auto discovery is basically looking for data types. I mean, basically goes and check what type of data, columns, and tables that are available. The AI role becomes more on the pattern recognition and the relationship that data has with the type that is already defined. So the role of AI in this context is basically to say, okay, I have auto discovery to discover a column that contains name data. So that classification of the semantics is really where we put the AI to play an important role, to actually understand that column contains certain type of data, and then I can tag that information and take actions on top of it. So it's really the piece that understands and classifies that data, so I can take further actions from the governance perspective. I don't know if those solve the two questions. Okay, how will the virtualization impact on the sources when everything is consumed by lots of users? The virtualization can be configured on with two modes. One is the push down mode, where basically the virtualizer actually takes the query and let the engine underneath to actually solve the question for us, for the virtualizer, to actually just bring the results. But the execution of the query is actually managed by the origin itself. In other cases, I mean, as we are connecting to HDFS or data lakes that do not really have an engine by itself, in most cases, the virtualizer itself acts as the engine. So the combination of blending or accessing that data, it can be configured according to the different types of technologies, either to push down or to retrieve all the information and solve the query in the virtualization layer. Both options are available depending on the data source. How exactly are semantics ontologies mapped onto datasets? Yeah, the semantics, I mean, we have this process of mapping. I mean, the last part of the use case, what I explain is basically, as this can be done manually, obviously, but done manually. If I go to a bank and I just say, okay, I have 45,000 columns and 4,000 business terms, I mean, it's something that is not really doable, or it's doable, but it will need a lot of human effort. So instead, the approach we got is basically use these classification capabilities that we have to understand the semantics of the data, and then propose that relationship with the business term that we have available in our dictionary. So really, when we say auto mapping, okay, it's a capability where we use artificial intelligence to basically do that relationship for us. So the results is basically that the artificial intelligence give us a potential relationship between the technical information and the business definition defining the ontology, with a level of confidence, okay, which in some cases, if it's very high, we can automatically set the system to actually put that relationship in place. If it doesn't have that level of confidence, well, we can review it manually, but it will be a subset of all the relationships that we need to build. Okay. Is it possible to get streaming events? Yeah, it's possible. I mean, as we are using, as I said, I didn't go too much into the ETL and the real-time aspects of the platform, but definitely yes, we have the engine that can process, and we have resolved in some cases IoT scenarios with with data coming from counters. We have, for example, a nice use case that we treat a water company. We are receiving all the sensoring information from the different pipes and central distribution places, and then we kind of do analytics on top of things. So definitely possible to do streaming architectures on top of the platform. Okay. So thank you all for coming, and hope you enjoy. Yeah, see you soon.